Okay, so we're going to officially start the event today. My name is Julian Blanco. I am based in Southern California. I am Sales Vice President at WEEI. We are a proud member of the LoRa Alliance. I want to first of all wish you good morning, good afternoon, and good evening to all of you. I know we have people from Europe, Latin America, and the US here. Welcome to this LoRa Alliance webinar, Smarter Decisions and Data for Agriculture in Latin America event. I will be moderating this webinar for you today. We will be starting today by giving you an introduction to the LoRa Alliance and LoRaWAN technology. After that, I will introduce you to our panelists who will present you their company solutions and use cases. At the end of all presentations, there will be enough time for Q&A sessions, during which we'll do our best to answer all the questions you have. You may enter any question you have during the presentation in the Q&A box on your screen, so we can gather those and analyze so we can answer later after all the slides are gone. So in a nutshell, let me start by giving you an introduction of the LoRa Alliance. The LoRa Alliance is a non-profit organization that plays a key role in the evolution of the Internet of Things thanks to a technology called LoRaWAN. LoRaWAN is a technology in the LP1 segment that stands for Low Power Wide Area Networks. Key advantages of these technologies are the fact the devices can run on very low power and thus long battery life, sometimes up to 10 years, over multiple kilometers, up to 15 years in rural areas. That means with one gateway or hub, you can connect a large array of devices and cover a large space without having to set up a more complex infrastructure with multiple hubs and data points. These are longer distances than some of the other existing protocols allow. Additionally, LoRaWAN technology can be deployed in rather complex wireless environments, and it's able to penetrate through walls for deep indoor deployment. We have actually experimented that using LoRaWAN technology and connecting things that are inside refrigerated chambers with thick walls. So we can attest to that. LoRaWAN has low data rate transmission, extremely long battery life, and is deployable in many different structures. It is an open source protocol, which means that anyone can access it, has access to it, and can easily join the ecosystem to add value. The next slide, please. Since the Alliance was founded in 2015 by a couple of founder members, it has rapidly grown into a structure of multiple hundreds of organizations all over the world, making it the fastest growing alliance in the ecosystem. Alliance includes some of the biggest players such as MachineQ, Orange, Cisco, AWS, and others. Thanks to this ecosystem, companies can collaborate closely to enhance the LoRaWAN protocol and offer certified and secure solutions to the market. That means that this enables the Alliance to cover multiple ranges of solutions and different verticals and offer comprehensive infrastructure in terms of different types of sensors and use cases. This next slide, please. In terms of global presence, the LoRa Alliance has become the de facto standard for LP1 globally, with networks spanning 161 countries and 143 operators around the globe. The three main goals for the Alliance are to develop, maintain, and standardize LoRaWAN open source protocol, use everywhere to roll out the network and connect devices, certify devices to ensure interoperability between LoRaWAN solutions, promote members, their products, and solutions. Next slide, please. On this slide, we can see what the LoRaWAN ecosystem is made of. Members of the Alliance range anywhere from chip manufacturers to system integrators and anything that comes in between. IoT connectivity with LoRaWAN starts with either the basic radio chips or the modules enabling embedding to the LoRaWAN protocol stack. Then used in devices as wireless modems to communicate data over networks, either public or private. That means that the ecosystem encompasses basically all needs to deploy multiple types of solutions that ranges from the initial building blocks of the technology up to the data needs and data consumption, going in between with all the different attributes that are needed for one particular use case. Data is collected by network servers and forwarded to application servers on the internet. This is how LoRaWAN enables the connectivity for the Internet of Things. Next slide, please. The LoRa Alliance operates in several verticals, such as agriculture, buildings, smart cities, smart industry or industry 4.0, utilities and logistics. These verticals all benefit from LoRaWAN technologies in their own way by taking advantage of the long battery life or the long range of connectivity, or the ability to go through thick walls and use and connect using a smaller footprint of infrastructure, or the ability to create a private network. In today's webinars, we're going to address smart agriculture. Next slide, please. Here are a couple of key differentiators or benefits of LoRaWAN. You can either use a public or private network to gather your data and manage automation. That means that you can build your own network just adding one access point or gateway connected with LoRa technology, or you can join a larger network that is provided by some other party. Public rollouts are like classic cellular network, whereas a private network can be an instant that runs on as well as Wi-Fi and can be either completely self-managed or support from an ecosystem partner like a system integrator. LoRaWAN is bidirectional standard, which means that it's easier to run firmware updates over the air. That means that you can, if you're connected to the internet with the gateway, you can manage not only the information that you're receiving, but also the devices that are in that network. It has very secure encryption with 2 layers. One is for the actual link, and the second is for the payload. The payload is the information that's being sent with the key information that the sensors are transmitting to the network. So much like cellular networks, the network provider cannot see the data that is passing through. Only the end user will be able to see that data. It is very energy efficient, as mentioned before. Battery life can go anywhere from 5 up to 10 years, avoiding having to change batteries by accessing often remote or complex areas. This allows, in many cases, us to place sensors and devices in very difficult to access spaces that are very hard to connect otherwise. Sensors are low cost, and the network has an easy setup process. Next slide, please. So now allow me to introduce the speakers, the LoRa Alliance speakers for today, that we will be presenting their use cases and solutions. Next slide, please. So the first one is me. Hi, again. Then we have Barney Barnowski from Tektelic. Tektelic is a provider of best-in-class carrier-grade LoRaWAN hardware and software for wireless networks based in Canada. We also have Patrick. I'm very sorry, I'm butchering all the last names here. We have Patrick Bretthauser, and Patrick, then you can tell us what your last name really sounds like. He is at Comesa, and they are a large system integrator that focused on irrigation and other solutions in Latin America, based in Ecuador. We have Jose Fernandez, CEO at Aon Chips. Aon Chips, it's IoT device manufacturer based in Barcelona, Spain, that is also serving our region in Latin America. Next slide, please. We have our friend Kirk Apperford from Semtech. Semtech is a semiconductor chip manufacturing that providing LoRa technology, the DNA for IoT. And finally, we have Scott Cubes. Scott Cubes is at OrbiWise, a Swiss-based supplier for industry-leading LoRaWAN network server, OrbiWAN. Next slide, please. So now I'm going to leave the floor for Kirk to present Semtech solutions. Thank you.
Thank you, Julian. Good morning, everyone, and thank you very much for taking time out of your schedules to participate in this webinar. I want to briefly sort of start out with our Semtech's newest product, which is the LR1110 chipset. And really what that is, it's a new chipset that really concentrates on location. As anybody knows with GPS or GNSS, LPWAN and GNSS don't fit hand in hand, simply because GPS has a high power consumption and LPWAN is low power consumption. Also, you have the indoor and outdoor issues. So Semtech sought out to really solve, number one, how we can get location both in an indoor and an outdoor environment with a low power unit. So, as you can see there, trying to solve indoor and outdoor location, arrival, departure of, traceability of articles that are out there. You can do geofencing, a lot of asset recovery. There's a lot of high dollar either products or equipment that's out in the field that you definitely don't want to lose. And again, you can, with the cloud services, you can set up custom zones, alarms for theft prevention. Next slide, please. So where really are the challenges that we're trying to tackle? So the existing solutions, they really require a lot of multiple vendors. So, when you're talking about, GPS or GNSS, you have that for your outdoor location, you have, Wi-Fi, potentially Bluetooth. There's also RFID is used for indoor tracking. So it really increases the bill of materials cost, your whole design, the complexity of everything that comes to that. Also, a lot really where you get to it is the existing solutions they're power hungry. That's just the way GPS has always operated to date. Obviously, over the past 20 years, power consumption, battery design has gotten better, power consumption has gotten less, but not conducive to work with LPWAN technology. So, with the high cost, the bill of materials, it's always been prohibitive to have a solution that transfers from indoor to outdoor to indoor again. You've always had to deploy two different solutions for those tracking. Next slide, please. So this will give you just sort of a high level overview. So I don't want to get really too technical with this, but really where we've made the difference with the LR1110 is that we're doing the location calculations in the cloud. It's not being done on the chipset level or on the local, like for example, field computers. So, for those of you that are familiar with large acre cereal farming, where you're using field computers and guidance out in the fields, a lot of you could be using what we call RTK technology, where you're receiving satellite GNSS signals, and then you're also receiving terrestrial GNSS correction signals. So that's, you need a powerful local computer in order to be computating your position in real time all the time. So that's really where the power consumption comes from. That's what we've endeavored to solve there by moving really all the calculations to the cloud. Next slide, please. So in this, you can see where we've really positioned the LR1110. Really on the left-hand vertical curve, you have your accuracy, and then along the bottom, you have your power consumption. So, we're not going to pretend that we have a high accuracy 2-centimeter solution. That's not the case. We're talking consistent solution that gets into meters. Indoors with the with the more gateways that you actually increase in an indoor setting, you can increase your accuracy. But where we do play well is in the power consumption. So GPS is really synonymous with higher accuracy, but also higher power consumption. So we're a little bit lower on the accuracy side, but obviously extremely low on the power consumption side. Next slide, please. So this will give you sort of an overall solution view of the architecture. The servers, the LoRaWAN server, application server, don't need to go. You can access both the LoRa Alliance and Semtech website if you really want to get into more technical data. But really the key that we're pointing out here is that the the data that's being transmitted is going to the cloud, and the cloud through the LoRaWAN servers and application servers is what's calculating your location. Next slide, please. So also, with that technology, we also are incorporating Wi-Fi, incorporating Bluetooth in order to get location a little bit more precise. So people that are familiar with Wi-Fi, they have MAC addresses. There's Wi-Fi lookup services on the internet to look up those MAC addresses for location, their packets, information, and everything else. Also, we can combine that with triangulation of RSSI signals when you now have more than 3 different gateways that those particular sensors are sending signals out to. So those, we're combining multiple technologies in order to be able to provide a low power, accurate solution. Next slide, please. So here's a little bit of what the agribusiness ecosystem can look like for this for these solutions. You have worker tracking, for example, in the palm oil business. You really need to know that your workers are spending the correct amount of time looking at the palm during the growing season. To be able to determine correctly that when it comes time for harvesting. So you can use that for worker location. Obviously, your in-field sensors, you have moisture sensor, temperature sensors, weather sensors. There's a whole variety of in-field sensors. Also being able to track your agricultural equipment. One of the key things is that, previously you would have sensors without location. But today it's really almost becoming a de facto requirement that every sensor is combined with a location. Everybody wants to see where that sensor is and the data coming off of that. Seed and chemical logistics, being the seed companies, being able to, you have reusable grain bins and chemical bins to be able to track those bins, but also to be able to track humidity, temperature, on how that product is actually being stored. Obviously, you have harvesting bins for product out in the field, for logistics, being able to track where those bins are in order to keep efficient harvesting, produce coming through, livestock tracking, whether you're talking cattle, sheep, out in the field, inside feedlots. There's obviously a lot of solutions out in the marketplace for that. Again, you have packaging and manufacturing facilities. So you're going to have, whether it's pineapple production, sugarcane production, you have the whole gamut of services that these companies provide. So they're growing product out in the field, and it's going right through to the manufacturing facilities. Global cold chain logistics. That's a solution that Semtech has tackled with new 2.4 technology to be able to track reefers. So reefers that are going to be shipped from, for example, Central America to North America with fresh produce, or produce from, even wine from South America to Europe over to Asia. You'll be able to track the health of those containers in real time. Again, silo bag sensors. Everybody's used to seeing huge vertical silos over the years. A lot of that has changed now to horizontal silo bags that are on the ground. Being able to check the temperature and humidity of those bags is essential. And next slide, please. I did want to spend a little bit of time on this vertical market structure, because a lot of us here, when we refer to smart ag or agriculture or sensors, our first thought process is a sensor at the grower level, which you can see at the bottom. Now that's perfect. Obviously, we need to see how we can increase production by reducing costs, reducing input costs, electricity, being able to save water. But for example, every one of these verticals that you see has an interest in the data. So, we're talking about a moisture sensor, or we're talking about a tracking sensor with temperature and humidity, or sensors that are in silos. Ultimately, the common denominator of all of those is the data. The data is used differently by each level. And sometimes, you need to look at it from both points of view. We have a lot of solution providers providing solutions that could be targeting the grower, but at the same time, there may be more value to it at a banking insurance level or an ag retailer level. And then at the same time, you'll have interest at the grower level for a specific solution. And they could be using it, for example, let's take viticulture, for example, the production of grapes. So there are solutions out in the marketplace where you're looking at optimizing irrigation in the vineyards. So there is obviously a direct ROI for that. But at the same time, those bottles, the grapes produced into wine, and they're bottled. Well, they're shipped. So, imagine a container that is filled with cases of wine bottles that the refrigeration unit went down, and it's sitting at a port in, for example, the country I reside in Costa Rica. It's being imported. It's sitting at port for 2 days under the sun, and the internal temperature got to 50 degrees Celsius. So you're going to get spoilage on that.
Thank you. Thanks a lot. If you have any questions for Kirk, we will have roughly half an hour after all the presentations are done. Thanks a lot, Kirk, for your very interesting presentation on Semtech. We'll move on now with Barney Barnowski from Tektelic. Barney, please.
Thank you very much, Julian. And Kirk, thank you very much for setting me up with that last chart. First of all, thank you all for joining the webinar. I'm happy for this opportunity to share with you some of the things that Tektelic is doing in smart agriculture. And I want to set the stage first with respect to how we view IoT and its benefits to agriculture. And if you recall Kirk's last chart, I'm going to talk about kind of the grower level, those sort of initial levels where the food is produced, or where the animal husbandry is happening. I'm based here in snowy Calgary, Alberta, and for the most part, we're surrounded by oil and gas, and we're also surrounded by a lot of growers, a lot of farms. And when we first introduced some of our devices, which I will introduce you here in a moment, a lot of the farmers that we talked to objected with the term smart agriculture, because their pushback was, well, we're already smart, right? And it's true. In order to be successful in any type of agriculture, you have to be smart, right? So can we make it at least a bit easier, right? So traditional farming, for the most part, relies on management of entire fields and making decisions related to planting, harvesting, irrigating, timing, and the amount of pesticides and chemicals that you use, and it's all largely based on historical data. When we flip the script around and we introduce networks like LoRa and devices that are based like on the LR1110, awesome device, by the way. However, our devices, which I'll show you here in a moment, are based on the 1262, so the previous generation. But when we introduce precision farming tools like that, enabled by LoRa, in contrast, we shift the delivery of data from the historical to the real-time delivery of information, right? So with the real-time data and information that combines sensor data, GPS information, mapping tools, all of this allows us to customize the care for the crops. And this is all done without increasing any labor. And at the same time, we reduce resources like water usage, chemicals, fertilizer, and most importantly, the farmer's time and the amount of time they have to dedicate to the care of those plants. So this technology, in summary, from my introduction, this precision farming, or the movement from historical data to real-time data, allows us to improve the time management, resource optimization like water. We'll talk lots about water here in a minute, chemical usage, and it allows us to improve yields. Now, how do we implement this, right? So I have a much more simplified picture here rendered relative to what Julian showed us about the LoRa architecture. Tektelic builds devices, end devices, which we'll talk about here in a moment, to address many different use cases. But those devices and the data produced by those devices have to be collected by gateways. And Tektelic builds probably some of the best gateways in the world. We have a full portfolio which can be deployed very successfully in a lot of different growing areas. Our gateways can be powered through solar type powering, backhauled over cellular. They're carrier grade, which means they can be safely deployed on all kinds of environmental conditions. Once the data is collected from the sensors through the gateways, that gets passed onto the network server layer. Scott Cubis from OrbiWise will talk lots more about network servers, so I'm not going to get into that. And ultimately, that data is handed off to that application layer. Whether that application lives on your iPhone or an AWS, that's really up to the implementation. What I'm going to concentrate on is the very left-hand side of this picture, which is how do we take the, how do we go above the chip level? How do we get above the silicon level? And we actually start collecting some interesting data. Next chart, please. So first of all, I wanted to sort of call out some of the use cases that we've been involved in over the years. And I kind of started with precision agriculture. That's kind of an all-encompassing term. But really what that means is, ability to know when to plant, how much to plant, water management. As part of that water management, the storage of the actual grains, asset tracking, livestock management, as well as smart greenhouses. And we have devices and applications for most of these areas. Let's start with the precision agriculture one. So let's jump to the next chart. Next chart, please. Thank you. So one of the first areas and one of the simplest areas but it has tremendous payoff in terms of resource optimization is the knowledge and the ability to determine how much water needs to be used, especially in areas where some of the more arid growing areas like say California, or here in Canada we have British Columbia where we have lots of viticulture and we grow lots of grapes for wine production. To help with this, Tektelic developed an agricultural sensor, which is essentially a soil moisture monitoring device, right? We have two variants of this device, but the point is that you drive this into the soil, and based on the gravimetric volume content of the soil the moisture in the soil, or on the tension that's applied to the probes, as in the case of our elevated mount, we're able to monitor the temperature of the soil, the water content of the soil, and we can also monitor the light conditions associated with that particular area of the field. This information can be relayed to the application and allows us now to make a smart decision about how much water, when to water, and basically be able to optimize the deployment of resources, whether that's a precision agricultural example, whether that's a tree farm, or even a golf course. Now, that obviously covers us for the water management piece. We've also encountered a use case that deals with storage of grain. So let's go to the next chart. So once we have successfully grown our crops, successfully grown whatever it is we're growing, one of the areas, one of the corner cases, if you will, of agriculture is the storage, right? And when it comes to storage, quite often, because we're dealing with biomass, there is the possibility of decomposition. And by virtue of decomposition, there's a possibility of actual fires. So we have developed a device that allows us to monitor the temperature of what we call mulch piles, but really it's the ability to monitor any sort of pile of biodegradable material, whether it's grain, banana leaves, wood chippings. As these things accumulate over time and potentially get moist, there's a possibility that they basically get so hot that they in fact combust. Here in Alberta, we store grain in big metal storage bins, and every year, one or two of these grain bins catches on fire, simply by virtue of the fact that there's been some decomposition occurring in the grain, and the temperature gets so hot that the grain bin catches on fire, typically resulting in a loss of $80,000 to $100,000 worth of grain. Right? So while the use case here is remarkably simple, because all we're monitoring for is temperature of the grain, it becomes a very powerful and very cost-effective solution in order to deploy, because the cost benefit just kind of writes itself. Okay, so that's kind of the growing, the monitoring. Let's talk about asset tracking. So this is something, the area that Kirk kind of expanded on. So let's talk about asset tracking and see what we're doing there. Can I see the next chart, please? Okay, so with respect to tracking, obviously, again, from a time management and from a resource management perspective, knowing where things are within the farm, within the ranch, is obviously very important. Whether or not you're trying to track large industrial assets like trailers, combines, you name it, people, or even the animals themselves. So for that purpose, Tektelic has developed a number of different asset trackers where we do in fact combine GPS, LoRa, as well as Bluetooth into a single compact form factor. And by optimizing the software on these devices, we can get potentially up to 8 to 10 years of battery life, especially on the larger devices, because we need to track sometimes assets that don't have a readily available source of power. It's easy enough to track a John Deere tractor because you have the battery, you have the thing operating. So it's easy enough for us to get GPS coordinates out of that. How do you get GPS coordinates out of a trailer? How do you get GPS coordinates out of a piece of equipment that may not necessarily have a readily available source of power? Again, LoRa is an extremely powerful solution for that, because by combining it with an accelerometer, by combining it with GPS, we can get 8 to 10 years of battery life. We also have smaller units which can be attached to staff, whether or not those people are the farm workers, you'll know where your farm workers are, as well as very small and cost-reduced devices that can be applied to livestock. However, Kirk also alluded to the idea of triangulation, and that is exactly another solution that we have introduced in the context of smart agriculture. So if I can see the next chart. So I started with the idea of deploying soil moisture sensors, right? And the soil moisture sensors, typically when you see the next use case, we can deploy potentially up to hundreds of them in the field. The question we always get asked is, that's all well and good, I've deployed these for the growing season, but now the growing season is over and I need to pull them out. How do I know where they are? All right. And LoRa has a very nice capability, which is time delay of arrival geolocation, which allows us to, through the power of triangulation, narrow in to the area of where those LoRa devices are, down to 20 meters worth of accuracy. And in line of sight areas, which is typically an agricultural type deployment, growing field, you can get down to as low as 10 meters, which means that once you've deployed these LoRa enabled assets, even though they themselves don't have GPS, you can still find them at the end of the growing season. You can pull them out of the field in order to be able to plow the field or do whatever it is you need to do in order to prepare it for the next growing season. And this, I would say, by itself is an extremely powerful capability. If you combine it with other things like the LR1110, you're going to have even more capabilities like this and LoRa obviously presents itself as an even better solution for agriculture. So just wanted to wrap up with one use case. We have lots of use cases, but on the next chart, just wanted to give you a quick example of a tree farm. Again, we have lots of local examples here because obviously there's lots of growing done in and around Alberta. The province next to ours, there's a hops and cider apple farm where, again, their primary concern was the amount of water they were using and where they were using that water in order to be able to use it as efficiently as possible. So they deployed our sensors, they deployed our gateways. We gave them a very simple application, and they had a very successful growing season. And you know, there's lots of examples like this. So if you would like to learn a little bit more, just shoot me a question in the Q&A. And I see Julian's already showed up on camera, so I guess I'm out of my 10 minutes. So if you have any questions, by all means, shoot us a note. And thank you so much for listening. Thank you.
Thanks a lot, Barney, for your presentation. Very insightful on Tektelic products. So let's go now to Scott Cubes at OrbiWise.
Thank you, Julian. And actually, that was a really great segue from Barney and Semtech. So anyway, hello, everybody. I'm Scott Cubis. I'm head of business development and sales in the Americas, other places for OrbiWise SA. We're a Swiss-based company. With our core product is the LoRaWAN network server. So you've heard quite a bit on solutions, which is fantastic. I know everybody wants to hear about that. And we have talked about some of the solutions that with our partners we're doing in Smart Ag. I guess we had a webinar 6 months ago, but wanted to take a slightly different tack with this to talk a little bit more about what you're going to be looking at from a network perspective to use LoRaWAN. And that's not to make it sound like it's a daunting thing. I think you'll find the technology is very easy to work with. You've got fantastic companies within the Alliance. You've met some, you're going to meet some more here in a minute. But just a quick about us, like I say, we supply the core network server. We've got a family of products in that, and I'll kind of go into that a little bit and what the LoRaWAN network server does. We're based out of Switzerland, but we do have other offices globally. Some of our partners we work with, you'd seen Tata and Chevron, I know mentioned before, but others within the Americas you can see here, and specifically ones that work with agriculture. So our friends at YEP and Caravan, which are sister companies located in Buenos Aires. YEP is doing more straight crop type stuff, and Caravan is working with cattle tracking and health monitoring and so forth. And then in Brazil, we have some great partners with Agro Things and now Opteam, who is getting into agriculture in Brazil. You can see that YEP and Caravan have moved beyond just Argentina and other countries as well. And then our friends at 11X up in Canada are starting to look at some agriculture stuff as well. And beyond that, we've got another half a dozen partners that can't really go into details on, but are working in various areas of agriculture. This is more on the end production, so I really liked Kirk's slide on the vertical market, which was good. But if you have more details, you see my contact details in our website. Some of the solutions, I mean, for instance, like this is Agro Things. This is their farm vehicle performance managing device, for instance, that goes into tractors and other vehicles on the farm. The asset tracking, which the guys have talked about quite a bit already. Farm facility monitoring, mentioned grain silo earlier, water regulation and irrigation management, the soil moisture. We mentioned the cattle elements, and then weather monitoring. So these are all very good use cases that we're directly dealing with now. So if you could go to the next slide, please. Okay, so basically with the network, you're looking at four main elements, and it's not to say there aren't other things you're going to need to consider as you go into starting up your LoRaWAN network. Of course, depending on how much you do it yourself and how much you involve, say, some of our friends here that we're all on this call, and of course we can support your efforts. But you have your devices, obviously, which are the important part. That's what's delivering the information that you need to take action with on your farms or other industries. These in turn, of course, are talking to your gateways. So these are folks such as Barney and Tektelic. And of course, there's multiple vendors in gateways and devices. The server, for instance, our OrbiWise LNS, but there are other options there as well. And then finally, you're connecting into your backend applications and application servers. So this is where you're getting to crunch your data and make something useful out of it. And of course, all of this is, in this case, what I'm talking about here, you're sitting on the cloud somewhere. Now, this can be a public or private cloud, which has implications. So you can go to an AWS, for instance, for a public solution, or if you have your own servers, you can set up on those as well. But of course, this is highly reliant on having a connection to the internet or to the cloud. And in this case, this is a full server. It's capable of, or this network, and with our server and other equivalent LNSs, can support, tens, hundreds, thousands of gateways, tens, hundreds, thousands, millions of devices on a properly scaled network. And this gives you the ability to work with multiple devices, multiple gateways, and different applications and application servers. So you can see the general path here. So it's always important to make sure you select good partners that can support you in building out your network. Now, in the case of agriculture, if you think about Kirk's very nice vertical market piece, if you're working with the upper elements of the network, so you're processing food, your storage, generally speaking, you're going to be able to use a network like this without an issue. You should generally have access to the cloud in some manner. So you run into less issues. So more of your issues there or around your IT challenges you may have, firewalls internal to companies, which, believe me, we've run into many times. But working with companies, it's very easy to work through this. Security, of course, becomes a big element, and this was touched on earlier as well. LoRaWAN is a very secure technology. So really, honestly, you shouldn't have to worry about that. And once again, with the partners that are available within the LoRa Alliance, we can address any kind of security concerns that you may have that come up. Now, of course, part of sizing a network like this, you have to have the ability to be realistic about where you are initially in setting up your network, and then where you're going in the future in terms of the size of your cloud setup, where you should set up, and how these things should be connected. And thinking about your devices and gateways, you've heard a bit about the devices, your applications. You can connect to many or even a single application server or multiple, like I said. Your devices and gateways, you're going to want to think about being ruggedized. This is an IP grade device and gateway. You have to consider your power consumption. This is, for example, a battery that you would use in many devices. So keep that in mind, and we can do this. We can go into this in some more details later. If you can go to the last slide then. So I'm going to touch on this real quick. So a good example with our friends at AgroThinks as an example, a new part of our family of LoRaWAN server products is what we call OrbiWAN Edge. This is a lighter weight version of our server, but with most of the capabilities. And it's designed to work in very remote locations where you basically can have a standalone network. So the connection back to the cloud is optional. So, I mean, if you want to get a satellite connection, there's multiple suppliers that work with LoRaWAN there. If you can manage an Ethernet connection, or if you can find some kind of wireless backhaul, but it's intended to stand alone. So the server would be combined with application or server or applications on a small, portable, lightweight server or computer on the farm, and it can handle multiple gateways, up to tens of gateways or down to single gateways. And then with the devices, it's intended for tens, hundreds, low thousands of devices. So it's really intended to be a totally intact network. So this is something kind of new. It sits in between an on-gateway server, which is supplied by any number of gateway suppliers, but is intended for an even smaller setup. So maybe single gateway and few devices. So this sits in between. But this addresses that issue you have in the case of like agro things, being up in a very remote area of Brazil where they have no internet connection, or it's intermittent or broken, that they can continue the smooth LoRaWAN operations with all the capabilities and features and functions that you have heard about and will hear about some more. So something to keep in mind there. I was trying to think of any other quick points on this as we start to wrap up my segment. The small app servers are actually very affordable. There's a number of these that can be available for $500 or so, I know. There's one that we recommend. And like I say, this is intended for small to medium-sized networks and in remote locations. So as smart agriculture is one application, but we also mentioned this in a recent oil and gas presentation as well as a good example. So with that being said, if you have any questions on this, we can field that in a few minutes. Thank you.
Thank you, Scott, for your time and for your presentation. Again, any questions you have, there is a box in the bottom right corner of the Zoom application where you can ask the questions, and we will make sure to answer during the presentations or after the presentations. Okay. Well, looks like now it's my turn. Hi, everybody again. I am Julian Blanco. I'm based in Southern California. I am a VP at WEEI Corporation. We are a company based in Silicon Valley, focused for the last 7 years on IoT solutions. We have solutions that range from agriculture to smart industry, retail, etc. In this case, we're going to focus on one piece of one solution that is aimed at the pig production. WEEI, in a nutshell, is a no-coding IoT platform that enables companies to build end-to-end solutions from connecting multiple sources of data, like LoRa-enabled sensors, gateways, PLCs, ERPs, etc., building the solutions in our WEEI cloud and deploying applications that not only show you information, but also enable you to automate processes by using LoRa's bidirectional capabilities. Next slide, please. So in this case, we're going to focus on one piece of one solution. And again, we have many other solutions that range from poultry to Industry 4.0. In this case, we chose to focus on the main challenges of pre-weaning process for pigs in the barns. And again, this is one application. We have many other cases that we can discuss and expand on. Focusing on that particular solution or issue, we see that the mortality rate for in the pre-weaning part of the pig production process is between 10 and 20%, and the major cause of that of those deaths is crushing. That is when the mother would sit down or lay down on top of one of the piglets and asphyxiate it to death. That accounts for roughly 70% of those deaths. The current process to control what's happening in these barns spaces is by having humans running around and making sure that everything is going fine. And if they hear a piglet squealing, then go fix that situation. That, of course, leads to many human errors, and nobody can be looking at the pigs 24/7, right? It's a very time-consuming process that again, it gives space for some multiple issues. Second is from a perspective of animal welfare. There are many conditions in the barn that generate stress on the animals that also impacts the well-being of the animals and the ability to gain weight and other factors like the air quality conditions, including ammonia and methane, the temperature and humidity, and the automated systems that are supposed to be maintaining that stable for the pigs. And finally, these types of challenges have a very large impact in the sow production. So roughly in a 1,000 sow or mother production, we are talking about roughly $60,000 or more that are lost due to these crashing events and other things that are preventable by using the technology. Next slide, please. So what is our approach to these problems and other problems is basically we go in and we take data where data is available. In some cases, the barns are enabled with PLCs for some data points. So we can, as we can integrate with that, extract that data and manage that in the cloud. And then we add a layer on top with LoRa sensors and actuators that will enable us to have the full visibility of what's going on and organize the data and show our customers all the historic information so they can make informed decisions. In this case, focusing on the crashing events, what we offer is a smart camera. The camera is placed on top of the place where the pig-weaning is happening, and basically it tracks objects, right? It can track the movement of the piglets and the limited but the movements of the mother as well, and can alert us if one of the piglets is inside the space that the mother is and there's a crashing event. That alert, that situation can trigger an alert that is a sound alert, a light alert on site, but it can also trigger an SMS alert and trigger an email in case it's required. So you don't need to necessarily rely on a person being 24/7 looking at every single cage, but having this type of intelligence built in, you can automate part of that process and send the person to the right place, and thus reducing the number of crashing events. The technology doesn't stop just with crashing. As we are tracking these piglets or these objects in the space, we can start looking at the behavior and tracking, for example, if a piglet is not moving as it should, comparing it to other piglets and figuring out if there is an issue with the temperature, with a disease or some other factors. All you can see on the graphic in the right, that those lines of different colors represents the movements of piglets in the space. So again, you can use that information to start inferring what is happening and making decisions to prevent issues or to solve issues that are happening at that particular moment. So the LoRaWAN technology enables us to add one gateway that could be from our friends at Tektelic, and be able to cover a whole barn or a whole site and connect every single sensor and data point to that gateway and route that back to the internet, not only for us to be able to see what's going on, but also to take action with controlling, for example, valves that could be from our friends at Aon Chips that are going to present later, or capture all the data coming from the sensors. So this will give you a 360 understanding of the environment the animals are in. And again, we are focusing here on the crashing, but it can also include information like temperature and humidity, ammonia and methane gases, concentration. With that, we can make choices to open a window, to turn on a fan, and to activate other devices, alerts, and show the information. Next slide, please. So here is what the pig farmer will be seen or can see. If you look at in the middle of the screen, you have two charts that I'm going to discuss briefly. One is the pre-weaning mortality. We can get that information initially by integrating the data that is coming from the ERP or the system that is used to manage that particular farm. Again, we can connect to the ERP, we can connect to the PLC, or in some cases we can even get that information automatically coming from the camera, right? The camera is detecting that there are, let's say, 10 pigs, and 2 days later the camera is detecting only 8 pigs. So we assume that 2 pigs are lost in the process, right? So this can give you a weekly accurate view of what's going on. The second one, the feedstock, I'm going to dive slightly deeper into that space in the next slides. But we can, using level sensors and flow sensors, start giving the farmer information to optimize the feeding process. And being the feed as such an expensive part of the process, when we improve a couple of points in the way that process is managed, that represents thousands of dollars of savings or improvements at the end of the year. Next slide, please. So here's another view. In this case, we are looking at environment, equipment, and alerts. I'm going to just focus on the equipment piece. We've seen in some cases that critical failure may happen in the equipment. It's rare, but it does happen, right? Let's say a fan gets jammed and there's no new air coming for the pigs, or there's an issue with the temperature or some other factor. That is a rare occurrence, but when it happens, it can lead to a very widespread mortality and massive losses, right? So in this case, we can, on one hand, control those devices, but we can also have sensors that are telling us if that device is working, right? For example, we can add an energy monitor sensor to the fan to make sure that the fan is actually consuming energy. So if the fan is supposed to be working, but it's not using energy, we can trigger an automatic alert and let the farmer know that there's something wrong with that fan, right? The same with a window that should be open or some other piece of the automated system that is again connected to the overall environmental information that we are receiving. Next slide, please. So here's another view that we provide. In this case, what we are seeing is, if you look at the two red squares there, those are crashing events that require attention. Then you have spaces that are empty. And then you also have information about milking events. Again, we can track not only crashing, but other types of events that happen with the piglets in the pre-weaning process. Below you have mortality and other data. Again, these dashboards are completely, you can automate, you can customize them to fit your exact needs and connect the data that is available. Next slide, please. So here is a quick view of a pig farm site. Again, with one LoRa gateway, you are able to connect all this space and get the data coming from all the sensors in every single room to track every single position, if that were the case. And you have there some examples of the types of sensors, from temperature, humidity, level sensor for water, flow sensor, flow meter, etc. Next slide, please. So to wrap it up, for this particular example of on pre-weaning and crash prevention, we are seeing a reduction of roughly 17% in mortality due to crashing, right? By implementing this technology, that represents several thousands of dollars that are saved every year by increasing decreasing the mortality of the animals. Second, we are seeing increases of more than 2% in the optimization of the feeding process by using the flow meters and level sensors and being able to optimize when and how the animals are fed. That again, the farmer will use that information to make informed decisions in order to increase overall productivity. We can also diminish or go to zero in terms of critical failure of machinery if we have the right sensors in place, reporting what's going on in real time. And finally, you get a 360 view of all the barn environmental conditions that can impact production, and that will enable better choices in many aspects, from the way the animals are inseminated to the way the animals are fed. So to wrap it up, at WEEI we provide a no-coding IoT solution platform that can connect to basically all available data sources. We connect to more than 700 sensors and actuators from multiple brands. And we enable this type of specific solutions that can be deployed in weeks, right? With no coding and no technical skill required. So thank you very much, and I'll be seeing you in the next slides. And again, questions, please add them to the Q&A. Now we have our friend Jose Fernandez from Spain to present us with Aon Chips.
Okay, so hi everybody. So I am Jose Fernandez, the CEO of Aon Chips. To present the company, we are a tech company based in Barcelona, in Spain. We are dedicated mainly to the design and manufacturing of IoT Internet of the Things devices to optimize industrial and agricultural processes. So we are specialized in the LoRaWAN control devices. We are members of the LoRa Alliance and had devices certified by LoRa Alliance, such as WaterSense, specialized in irrigation control. This is an interesting device that I will try to introduce in the next slides. Next, please. So, which issue can Aon Chips solve? The use case that we try to present today is the irrigation control. How to do efficient irrigation control. The issue that we try to solve is that the farmers, as my partners have explained in their presentations, dedicate a lot of large part of resources in some activities like controlling irrigation. So they have to travel to activate irrigation valves. They spend a lot of time reviewing the correct functionality of the system. And in some cases, they have to change the climatic conditions, and they have to change also the irrigation according to this climatic condition. So all this is labor cost paid by the owner, and is money that we want to be more efficient by the owner and win this money that is a scrap that they are throwing. So the solution that we are proposing is Aon Chips use Internet of the Things to offer reliable hardware devices, easy to service, cost-effective, and standard with LoRaWAN technology. In this way, farmers can monitor their crops in real time and control irrigation and resources. So it means cost savings by being more efficient. Next slide, please. So which are the variables that we should measure in the case of the how to manage the irrigation? As my partner before, like Tektelic has explained, one of the more interesting variables to measure to control irrigation is the temperature and the soil moisture. So we have different solutions in the case to measure the irrigation, the soil. Sorry, there are solutions with different levels of how to measure the soil with different depths. There are multi-level or point measurement. There are various measurements methods, and it's interesting also the way of how to calibrate the sensor according to the features and according to the soil. The other variables could be the soil water tension and also the ground temperature. Next slide, please. The other interesting things that we should measure, like a variable, is the weather station. The weather station is an instrument that gives us the air temperature, the humidity, the barometric pressure, the soil radiation, the rain volume, and also in some cases could offer the possibility of frost warning. Depending of the climate is interesting. The temperature, the wind speed, and also the direction of the wind. These are all variables that we should identify to control efficiently the irrigation in the field. Next slide, please. The other interesting variable to measure is the water flow consumption. We have cases that we explain you later, or with our partner of Comesa. What is interesting to measure the consumption of the water. There are, in some cases, flow meters with a high volume, like a kind of flow meter called WEEI, that it could have more than 300 cubic meters per hour. And in some other cases, we have to measure low consumption with other kind of LoRaWAN flow meter of 1 inch and with a low flow, like 4 cubic meters per hour. Next slide, please. So the idea is to use all these variables that we have identified to control the irrigation efficiently. And the device that we're proposing is the WaterSense. The WaterSense description is a WaterSense a smart water control able to manage till 4 irrigation outputs with an independent irrigation calendar per output. We can use large valves that can be supplied to 25 volts AC, 205 volts AC, till 480 volts AC with a wide range of possibilities. Also, we are controlling pumping motors with this device. The other interesting connectivity that we use is the MFC port. The MFC port is used to commissioning the device through a phone and reduce time for installation and maintenance. The other interesting thing is the battery life of the device, that we are warranting more than 10 years in a device that can manage actively the outputs of the valves. So we are looking for a cost reduction, avoiding wiring because installation is near to the valve and it doesn't need external supply, and free of maintenance during 10 years, and reduction in water consumption. Next slide, please. So this is an example of a dashboard that we have integrated in the field, and the WaterSense is offered with 3 different working modes normally. The manual output that offers a control on-off of each valve, the irrigation according to a calendar, to a parameter calendar for each valve, and the last working mode is the more efficient, is a control irrigation according to a trigger that we program according to the value of a soil sensor that we assign to each output. So if the trigger is not arriving to this value, then the activation is working, and in the case that the trigger has arrived to this value of the most soil sensor, the activator is inhibited. Next slide, please. So these are examples of how we're using WaterSense. For example, the number 1, we have connected to large valves with a low pressure in drip irrigation near to directly in the valve box. Here we have two large valves with a device. In the other slide, we have irrigation controlling in the field of the olive trees in Seville, in Spain. Next slide, please. This is another example that we are using. We are controlling solar pumping with our device. So this is typically with the areas without electricity. We are using WaterSense to activate the solar pumping according to the value also of a soil sensor. Next slide, please. These are some examples of WaterSense that we are using in Mexico with our partner WEEI IoT in greenhouses. Next slide, please. And this is the final use case that my partner Patrick from Comesa in Ecuador is going to present. Is a very interesting use case that we have been deploying in managing the irrigation in banana. Next slide, please. And finally, if you want to contact to anything regarding to our devices, here are my data, and please. We'll find and the questions. Thanks. And I present to Patrick.
Thank you, Jose. Hi, Patrick. The floor is yours.
Yes, well, good morning. Basically, what I would like to present is an application which we have developed here in Ecuador for banana plantations. Next slide, please. So basically, in Ecuador is the largest producer of bananas in the world. The country has 33% of world market share. They export 357 million boxes annually. There is a plantation size, there's 200,000 hectares of plantations and 8,581 units. To see larger plantations, we have 800 units of 100 hectares or more. So this is really a large industry here in Ecuador and still needs a lot of technification. The next slide, please. So what we made, the analysis we made was the following. We see that you need about a valve every 10 hectares. So calculating with the size of the plantations and so on, we estimate that there's about 20,000 valves installed in the country. So the potential market we feel is about 10,000 valves which need to be automated. Okay, next one. So the first thing we did, because this technology is new to the market, so what we really did is introduce the gateway to the farms at our cost. We installed it. We made the test. We test the coverage of the farm to be able to convince the owners that this is a technology which can be applied for many types of applications. Could we see the next slide? So this is, for example, the application on a 350 hectare plantation, banana plantation, where we basically analyzed many spots to see what the coverage was and found out that most of the farm was covered. You will see on the top right part of the farm, that's where the gateway was. And analyzing this, we decided that probably the gateway had to be moved to the center of the farm. Can we see the next slide, please? So here you see clearly what the areas are which were covered and the areas at which were not covered, which were basically geographical, let's say, inequality of the land. So basically, we see that with one gateway, we covered just about the whole area. And on top of it, we covered the area with sensors, which were at ground level or up to 1.50 meter height, and also within the buildings. So that really opens up the possibility of many applications. The next one, please. So the irrigation systems, we can perhaps go to the next one. Normally the farms have the following thing. These are big farms, so either they are activating their valves manually, which is the most cases in Ecuador. They have people running around opening and closing valves. And the people that have automatization, what they do is they have these small valves near the well site and a hose with water pressure going to the valves in the field. So they have to have a whole installation, which is complicated, it's expensive, and is very prone to damage. So that's basically what you find in automated farms. Now let's go and see the LoRaWAN, which will be the next. This is the application we designed so that we can control the big valves in the field, which can be about 5-6 inches diameter, and we control it with a small valve, which is a control valve, and we use the water sense to receive the signal to this valve. Now the next one, please. So How does this work? That would be the next slide. So basically, we have the irrigation schedule, which is the graph you see on the left side, and on the right side you see how the valve works. On the high part, on the top part, you see the control valve, which is activated with a water sense. And in this case, it's a normally closed valve, so there's no water going through. And in the next slide, we see now that we've opened the valve and the water goes through. And you see on the left side that it was activated by the software, which comprises all the equipment that you can have in the whole irrigation system, from the well to the water valves. Now the next one, please. So what is the equipment we've been using? We are combining everything into the irrigation system. The water, on the right side, we have the weather station, which is a PESTEL weather station, which works also with LoRaWAN. Then we have on the left side, you see on top, you see the water sense. Below that, you have an equipment which is from Senseo. This equipment is a communicator for the humidity sensor, which you have in the ground, which is in the middle, on the lower side. You see that. The box which you see on the left side, the lower part of the mast, is where the control valve is. We put this into a box, which was perhaps not necessary due to the fact that people might want to damage it or it might disappear for some reason or another. So now you see that from all these on the center side, you see the two hoses going into the main valve, that's the way we control the main valve through the control valve and the water sense as communicator. So basically, this is the setup. We've integrated the weather station, the humidity sensor, and the irrigation system. The next one, please. This is you see the banana plantation on the bottom. You see it's a very large plantation. Here we took the photo from the mast, and you have the gateway there, which is a Swiss-made gateway. So basically, all this whole setup gives us various advantages. We have a lower investment cost. We have security that it's really done, the work is done, and we have very good profitability. Can we see the next slide? Okay, so here we took and made an example of a 100-hectare plantation, which we have about 10 valves, which we have to irrigate, and 2 to 3 persons working, opening and closing the valves, depending on the time of the year, where it's sometimes more wetter and sometimes drier. So the hydraulic valve cost, which would have to be invested for this manual operation, would be about $500. And what we calculated is with the labor, this is of course, these are not all the detailed data, they're very summarized. The savings are about $22,000. The investment we have in the first year is $15,200, which includes all these valves. And the payback we've calculated is 8 months. So this is really basically a no-brainer, because the people, the project is paid by the savings in the first year. So all these advantages are leading to the fact that we've made proofs of concept and are now negotiating already the installation in various farms or groups. We're working now with Dole. We're working with a big group here in La Favorita in bananas and other smaller farms.
Thank
So
you.
this is
Thank
basically
you.
what we're up to here in Ecuador. Mm-hmm.
Thank
Okay.
you, Patrick. Thank you, Patrick, for your time and your detailed presentation about how to manage water irrigation in banana plantations. So
Okay.
now it's the time for Q&A. So I would ask for the different speakers to be available to answer questions. I believe most of the questions that were asked on the Q&A side are already answered in the system. So if you are curious about your question or somebody else's question, you can just click on the Q&A tab and see the questions and the answers. We have a couple of questions that we captured during this conversation, and we wanted to throw here to have an open discussion. So I don't know. I'm gonna, for the purpose of being efficient on time, I'm gonna basically address some of these to our panelists. So the first one would be, why should we use LoRaWAN in agriculture? And that goes for our friend Kirk at Semtech.
Well, specifically, it really gets into cost. So when you start talking about all the verticals that are available, you're talking oil and gas, medical, industrial, smart cities. All of those verticals generally have more available funds to invest. Agriculture is generally price sensitive. And the technology of LoRaWAN, the whole technology around it of, the cost, the distance, cost of gateway sensors and everything, it's really conducive to work with the agricultural marketplace.
Thank you, Kirk. Next question should go to Barney at Tektelic. So what is the effect that you're seeing, real effect that you're seeing with actual farmers by implementing these smart agriculture solutions? I don't know if we have Barney. Okay, so then I'm gonna ask that to Jose, that I'm sure has a proper answer for that question.
Sorry, could you repeat the question,
yes,
Julian?
Yes.
Oh, sorry.
What is the real effect for farmers by using this type of technology implemented in their fields?
I think that for the farmers, the use case that Patrick has presented is to be more efficient and to win this source to do other things. So I think that the technology, the LoRaWAN is a technology for, in our case, for precision agriculture, because it's deployment and the ability to provide coverage in our geographical area. And I think that we are trying to be more efficient and to be efficient and to give these resources for the final user.
Thank you, Jose.
To solve.
Thank you, Jose. One for Scott. So what happens in deployments that have poor connectivity, that maybe have intermittent internet, or they're connected via cellular that is not a strong connection?
Sure, that's kind of back to the second network setup I mentioned, which is if you do find yourself in a very, very remote location where you don't have that internet connectivity, or maybe it's intermittent or broken, which is the case, like I say, that we run into with agro things, and we've had this with some others as well, but that was a really good case. You have two options. If you want to connect into the cloud, then you have to look at something such as a satellite connection, and EchoStar, Inmarsat. There's a number of satellite companies that have worked with members of the Alliance for that type of backhaul. Some folks I know look at point-to-point wireless communications, specifically set up for their backhaul. Generally speaking, if you don't have the internet connection, that means you don't have a wireless network, an operator. So you can't rely on that. So you have that. Or the other option is, like I mentioned, our edge server, or you do have some lighter weight on gateway solutions and you basically run a localized LoRaWAN network. So you keep everything within that area. So you have your application to analyze your data, you have the server, your gateways, devices, everything is localized on that particular farm or region. And then you can handle that and run a very nice LoRaWAN network. So.
Thank you, Scott. And like, I have two more questions. One is why use standardized type solutions? And this I'm gonna jump on that one as WEEI. Scott mentioned we within our capability as a platform, we can also deploy a standalone LoRa network with a full functionality, from getting information from sensors and also controlling actuators and concrete actions that happen in the field. From our standpoint, the ideal scenario is to have deployed standard solutions that can be customized for specific customers. So we share today a solution around pre-weaning for pigs, but we also can have solutions for poultry, solutions for irrigations, and solutions for Industry 4.0 that not only take advantage of LoRaWAN technology, but also include information coming from PLCs, ERPs, and other sources of data. So you get a whole view of what's going on and can customize a very, very unique solution that fits the customer's needs. And finally, one more question for Patrick. I don't know, Patrick, if you're available, if you can share with us what is the main issue that your customers are facing when buying these irrigation solutions, and how you're able to come around and offer them the solution even with those pain points. Patrick, you're in mute.
Okay. Basically, what we found as a bit the resistance is due to the fact that the people don't know about the technology. This is really new in Latin America. In the case of Ecuador, we're just about the only ones that are really promoting it. And that causes a bit of resistance, or it takes more time, I would say. More than resistance, it will just take more time. The other thing is they are used to their actual way of doing things. And what has happened is, for example, for the humidity sensors, they had bad experiences with the supplier. So you know that bad things usually circulate like bushfire, and people start believing in them. So we're trying to convince them that if you're going to put water on the earth, measure the water you have in the earth so you can regulate. That's usually the process you should have. But that's basically, it's a question of more information, more education, making more manuals available, and so on.
Perfect. Thank you, Patrick. So to wrap up, you have our contact information. We are happy to answer more questions. Lately, most of the questions were already answered in the Q&A box. We would like to thank everybody for your time. The solutions that we all presented today are available for the different countries in Latin America, and can span from multiple verticals, multiple specific solutions. There's a lot of different sensors, actuators, and network infrastructure that you can take advantage of. So thanks a lot to everybody for participating in the call today. We hope this had been informative for you, and we hope to do business with you in the future.